So some of these integrals that we want to evaluate are going to be a little bit more complicated and not as straightforward as just taking one antiderivative. So suppose we wanted to evaluate this indefinite integral right here. Our antiderivative formulas don't tell us how to evaluate integrals of composite functions. And what I mean by a composite function, obviously, is a situation like this here where we've got a square root of a quadratic, right? So this is two functions. Our inner function will be a quadratic, our outer function will be a square root, and then on top of that, we're multiplying that composite function by 2x. So it's a difficult situation, and we don't necessarily know what the exact antiderivative of this is just by using power rules or things of that nature. So what we're going to do is we're going to use what we call a u-substitution. And we're just going to say, let's let u, the variable u, represent that interior function 1 plus x squared. And you're going to see something nice that comes from this, because if we say that u equals that function, well then what does du equal? Well, that's just going to be the derivative of that function with respect to x. So du would be 2x dx, right? If I took the derivative of each side here, that's what we would have. So what we can do then is use these two pieces and fit them into the old function. So I'm going to say what I have here is the integral of, and I'm just going to rearrange it, the square root of 1 plus x squared, and I'll put the 2x times 2x dx. This is just another way that I could look at this same function, right? These are the same thing. But the reason I'm writing them that way is because you'll notice this here is going to end up being just the square root of u, and this here is du. So we have those two components that we just specified in that let statement, and it's going to simplify this whole thing for us. So I could rewrite this then as the integral of the square root of u du, which makes this a very easy integral to take, because now I just have to take the integral, or the antiderivative, of u to the 1/2 power. So I can do that pretty easily. That's just going to be u to the 3/2 times 2/3. And that's just the power rule. Don't forget plus c. So in the end, I have to remember that I did say that u was equivalent to 1 plus x squared, so I'm going to substitute that back in, and my final answer is going to be 2/3 times 1 plus x squared to the 3/2 plus c. And obviously there are other ways that we could write this, right? I could write this as 2 times the square root of 1 plus x squared cubed divided by 3 plus c, and that's probably a nicer way to look at this, but there are a number of ways we could write it. This is still the antiderivative, or the value of that indefinite integral. And don't forget we need that plus c because it is indefinite. So the reason we're able to do this is just a formal definition here. If u is equal to g of x is a differentiable function whose range is on some interval I, whatever that is, and you have a function f that is continuous on I, that same interval, then the integral of f of g of x, of that differentiable function, times the derivative of that g of x function with respect to x is equal to this integral here. And that just comes from the idea that if u is equal to g of x, then its differential du is equal to g prime of x dx can be used as a substitution tool here. So the substitution rule says that it's permissible to operate with dx and du after integral signs as if they were differentials. So let's do another example of this. So this integral would be challenging to do just by trying to guess and check functions that might have this exact derivative. So let's use a u-substitution here. And in thinking about what my g of x or my u is going to be, I'm going to try to find something within the innermost function that contains components of other things that are being multiplied here. So for example, I've got cosine of this interior function, and I'm noticing that the derivative of this interior function would be an x cubed function. And we have an x cubed here, so that's going to be useful to us. So I'm going to let u equal x to the fourth plus 2. And if that's the case, then du is equal to 4x to the third dx. Now we want to make sure that we've got every component of this function covered here. So I'm just going to think about things. I've got the x to the fourth plus 2, that's there. And the only other part of this that I need is I need to make sure that I've got the x to the third and the dx. I don't need that 4. I only need that component of this expression. So I'm actually going to move that 4 to the other side and just write this as 1/4 du x to the third dx. So then when I rearrange this and rewrite this and substitute these components in, I'm going to have exactly what I need and an expression to represent exactly what I need. So let's rewrite this integral. So I'm going to rewrite this as, just so that we can see what we're looking at, the integral of cosine of x to the fourth plus 2 times x to the third dx. And this just helps me visualize what's happening here. This is my u, and this here is 1/4 du. So now I can rewrite this as the indefinite integral of 1/4 cosine of u du. And this is going to be a much easier thing to evaluate because first thing I can do is actually remove that constant. Alright, so now it's just a matter of taking the antiderivative of cosine, and so that's going to be equivalent to 1/4 times sine of u plus c. And now I can finally substitute that x to the fourth plus 2 in for u and rewrite this as 1/4 times sine of x to the fourth plus 2 plus c. And you might be wondering, well, why doesn't this say 1/4 c, right? Because we could think of that 1/4 as needing to be distributed. It doesn't matter, right? Because that constant can be anything. So let's have it be 1/4 of that anything. It's still just anything, right? It's just a constant number. So yeah, you could write 1/4 c there, but it really doesn't make a difference. So then this is our final answer, and we want to make sure that in our final answer it's a function of x, not a function of u anymore, so be very careful of that. We'll just fit one last example into this video here. So again, this is a complicated integral. I don't want to try anything like a reverse quotient rule or something like that, so I'm just going to look for an interior function that would be a good thing to represent u. So I'm going to let u represent 1 minus 4x squared here. And if I do that, then du is equal to negative 8x dx. All right, so I'm looking at things outside of that composition function that I'm not going to need here, right? So looking at another way to write this, you could say that that is x times 1 over the square root of 1 minus 4x squared. So the composition that I'm referring to is the 1 over x function, or what we're going to call 1 over u. 1 over square root of u, rather. So the extra thing that's left over here is this x, and I want to make sure that's accounted for, but I don't need this negative 8 here. So I'm just going to rewrite this then as negative 1/8 du and x dx. And now this is the component that I need to make the direct substitution. So I'm going to rewrite this, and this is not a step that you have to take, but I find it's easier to look at the function, in this case, as 1 over the square root of 1 minus 4x squared times x dx, so that I can see the components that I'm replacing here. This is u, and this is going to be the negative 1/8 du. All right, so now I can rewrite this, but with my u substitutions. So it is the integral of 1 over the square root of u times negative 1/8 du. And remember that negative 1/8 is a constant that I'd like to remove. So negative 1/8 times the integral of, and I'm going to rewrite this as u to the negative 1/2 du. And that's going to make it a little easier for me to view that as a power rule rather than trying to do something with the fraction that I've got there. All right, so now I can just use the power rule or the reverse power rule on u to the negative 1/2. So I have negative 1/8 times, well, negative 1/2 plus 1 is going to have to be u to the 1/2, and it's going to have to be 2 u to the 1/2. All right, which obviously must be plus c. All right, so the last thing that I'm going to do here is distribute that negative 1/8. So I'm going to have a negative 1/4, and I'm going to replace that u with what it actually represents, which is 1 minus 4x squared. And the 1/2 has now been turned into a square root there, plus c. We'll do some more examples on Monday.